In example 4, they tell us that f of x is an even function and that the integral from 0 to 3 of f of x dx is equal to 8. And they want to know what is the value of negative 3 to 3, the integral from negative 3 to 3 f of x dx. So to answer this question, you kind of hinges on what an even function is, and in particular, what type of symmetry you have if it is an even function. And so let's take a minute and think about that. So even functions are functions that have symmetry about some sort of vertical axis. So they have a vertical axis or vertical line of symmetry. They also have the same end behavior on both sides. So for instance, a parabola is a very simple and elementary example of an even function. It goes as x approaches negative infinity, the function goes up and to the left. As x approaches positive infinity, it goes up and to the right. And it has symmetry, in this case about the y-axis. Okay, well, let's just say for a second that, I don't know, we've got some sort of an even function here. I don't know what it is, but the area under the curve bounded by the x-axis between 0 and 3 is equal to 8. Well, because we have symmetry about this apparently 0, which is in the middle of the integral from negative 3 to 3, that means that the same function is reflected across that y-axis, and from negative 3 to 0 we have the same area, so that's equal to 16. Okay, well, what about this? An odd function. Okay, so just like the quadratic y equals x squared is a go-to easy function for thinking about even functions, the cubic is my go-to function for thinking about odd functions. So let's just think about a cubic equation here. So the end behavior is opposite. So as x approaches positive infinity, we go up and to the right, and as x approaches negative infinity, we go down and to the left. But you'll also notice that we have 180-degree rotational symmetry, and that is true for odd functions. And so what that means for me is if the region bounded by our function to the top, the x-axis to the bottom, and between 0 and 3 is in fact equal to 8, that means that the same area over here is bounded as well. The problem is this area is below the x-axis and is therefore a negative area. And so we have 8 plus negative 8, which is equal to 0. So symmetry can help us answer questions about definite integrals and areas. So even and odd functions.